This is part 3 in our series on basic supply chain modeling using Logix. In this tutorial, we'll be adding suppliers to your supply chain model, optimizing inbound logistics, calculating inbound quantities, and showing how inbound logistics impacts your results. Let's start by taking a look at suppliers and how to add supplier data to your model. We'll take a look at the example from the demo where we have two suppliers, US Supply Incorporated and Megaparts Incorporated, one in Salem, Virginia, the other in Austin, Texas. We have their locations here. The geocoding can be done automatically by Logix, or you can add that yourself. Both of these are represented as suppliers for all regions using the wildcard asterisk or all in the region code. This can link to all distribution centers and all customers, no matter what region they're in. Product A here is represented by the total quantity of either production or throughput or availability of product A from US Supply or Megaparts. We're also showing Shanghai Supplier. We'll be using this in a subsequent tutorial. These suppliers have transportation variable costs of 12 cents a mile. And looking over here, we see that the ship unit is per 40,000 pounds. Source percentage, represented in this column, is a very important feature of Logix. In Logix, you do not need to specify the quantity of supply. There are two ways that Logix will supply this automatically for you. Logix will calculate the inbound quantities as, in this case, 50% of the outbound quantity. For Megaparts, with 100%, Logix will calculate 100% product inflow to match the product outflows. These numbers can be set in any proportion. Now let's take a look at our Logix model. In our last tutorial, we had shown how to add distribution centers to our model, either existing facilities, represented here with a region code matching the region code for each of our customers, or maybe some candidate facilities. We can import our data using the Logix Data Import Wizard, or in this case, we'll just click on the demo here, where that data has already been imported for us. Here again, we're seeing US Supply Incorporated and Megaparts as our two suppliers. We have our usual 16 distribution centers and depots, and again, our 48 customers with population data representing our demand. Now, if we click on each of our suppliers to take a look at a little bit more detail, again, we see maximum quantity, product cost, transportation, variable, and fixed. And if we click on details, we can see here that our transportation is road and our ship unit is 40,000 pounds. Our source percentage, if we recall, is 50% for US Supply based in Salem, Virginia. Similarly, we can take a look at Megaparts, source percentage of 100%, maximum quantity throughput or manufacturing. Product cost is 2 cents per product. And again, we have our transportation rates represented here and our ship units here. Now when we run an optimization, we have a few choices that we can make. We take a look at network optimization. We have a choice of optimizing the inbound and the outbound simultaneously. We're turning this feature off, which will optimize the outbound first and then match the inbound to that optimization. The choice is yours to make. We'll click on Optimize Inbound and Outbound simultaneously. This will allow Logix to take a look at both the inbound and the outbound side of your problem simultaneously and optimize the location of your facilities based on both the inbound logistics and the outbound distribution. You can set the number of sites. We set the number of sites at 2 in this case, and click our supply chain network optimization. Now we have the locations in Denver and Ashland, Kentucky from our existing and candidate facilities that we represented to the model. But you'll also notice that US Supply and Megaparts, our two suppliers, are represented in the solution for both sites. And if you recall, Megaparts at 100% is going to match the outbound flows in our problem at 100%. US Supply at 50% is going to be 50% of our outbound flows. Ashland, Kentucky, again using the same ratios, Megaparts will be represented at 100% of our outbound flow, and US Supply, again calculated automatically by Logix, will be represented by 50% of the outbound flows. This is very typical for a Logix problem using prescribed inbound percentages or source percentages. Now again, you have similar capabilities to optimize proximity, either by clicking on our proximity radar. And let's reduce this to about a scale of 400. And again, we can see that the exact optimum is close to Ashland, Kentucky, but really about 83 miles northeast of Ashland, Kentucky, near Dexter City, Ohio, in this particular case, with a little bit of a reduction in cost, about 1%. Now, if we click on proximity and then run supply chain optimization, again, we'll see that the solution is displayed here, Dexter City, Ohio, 82 miles northeast of Ashland, Kentucky, and Hanksville, Utah, at a further reduction in cost, at a cost of about $19,745,000 for the optimum results. Clicking on Show Data, and again, here's our original problem. You can also run a simulation of your problem, as we did before, by clicking on Simulation. And again, we have our 6-site solution at $22.2 million. But again, here we have our suppliers also represented in our solution. So now when we're comparing the optimum results to the simulation results and displaying the analytics, now we have our inbound and our outbound represented in the solution. So we have an 11.4% reduction in cost overall for our supply chain. We can also optimize this problem in a slightly different way by turning on sourcing optimization. Now, instead of using the sourcing percentages, Logix will calculate the inbound supply from limited supply from US Supply and Megaparts that should go to the optimum distribution centers. Again, using supply chain network optimization with inbound optimization turned on in this case. Now you can see here that Megaparts would be used up to the limit of 103 million for distribution to Denver, whereas US Supply would be used for Ashland, Kentucky. And in fact, when we take a look at that solution using our maps, You can see here that Megaparts would be our supplier for Denver, and Ashland, Kentucky would be supplied by U.S. Supply. So the choice is yours, whether to use inbound sourcing optimization and using the maximum quantity here as a threshold for either manufacturing or product availability. And similarly here for Megaparts. Be careful in the solution. If your availability of product doesn't match your demand, Logix will allocate as much of the available supply to meet demand, but there may be a shortfall, which you will be alerted to with a message from Logix. In our next tutorial, we'll take a look at how to add pooling facilities, consolidation facilities, and inbound warehouses.